All right, we got here one of our reviews. We actually got two different packets of reviews for algebra this year. So here's one of them, and I'll do some of it in this video and then break it up and do a little bit more. I don't want to have the video get too long. So first thing that we're working on is just solving equations. So you're just trying to get x by itself. You're trying to do the same thing to both sides, and just sort of clean things up. So the first thing I notice is this negative in front of the parentheses, so I can distribute that. So I didn't do anything to the left-hand side. Distributed the negative to the right-hand side. Now I'm going to add x to both sides because I want all my x's to hang out on one side of the equation. So if I add x to a negative x, it goes away. Then I'm going to add 5 to both sides. So I end up with 4x equals 7, and then divide both sides by 4, and that's my answer, x 7/4. If you grab a calculator, you get 1.75, that's fine, but just leave it 7/4. Really similar process with number 2. I'm going to distribute the 1/3. So 4 minus 2x is 1/3 x. Oops, not plus, minus 2/3. Then I'm going to get my x's all over on the left side, just showing you that this isn't the only way you have to do it, but this is really similar to what I did last time. 4 minus 2 1/3 x equals negative 2/3. Then on the left, on the first problem, I did get rid of the 5. I did plus 5 to get rid of the minus 5. Here I'll do minus 4. So now we have negative 2 1/3 x equals negative 4 2/3. And you divide, just like I divided before. And this looks really hard, but actually the numbers worked out really nice. 2 1/3 goes into 4 2/3 exactly twice. So that worked out super nice. So the answer there is x is equal to 2. All right. You can check your answer if you want by plugging it back in. Sometimes it's nice to do this, especially with a problem like this where the numbers are kind of tricky. So if I take x equals 2 and I plug it in right there, I get 2 minus 2, which is 0. 1/3 times 0 is still 0. If I plug it in on the other side, I have 4 minus 2 times 2, which is 4, and that does equal 0. So that's another just confirmation that we did it right. All right, let's look at that third one. I'll clear the page just to get a little cleaner. So here we've got 2x minus 3 over 2. One thing you can do is you can just multiply both sides of the equation by 2, because over 2 cancels times 2. So now I don't have any fractions anymore. Please remember to multiply x and 1.5 by 2, and I get 2x minus 3 equals 2x minus 3. Look what happens if I try to keep following the steps of before. I get negative 3 equals negative 3. That is something that is definitely true. What that means is no matter what x is, the left side and the right side are both the same number. So we can say there's infinite solutions. I'm just going to write inf solutions. All right, let's look at the last one. Same sort of idea, just with some decimals in there. Negative 0.25 times 4 is negative 1. Negative 0.25 times negative 3 is positive 0.75. And then haven't done anything with the right-hand side yet. Then I'm going to get my x's all over on the left side. Again, you don't have to always get your x's on the left side. I just already did it that way 3 times, so let's keep it up. Then I'm going to get my not x's, my other numbers on the other side. And then I'm going to divide by the number in front of x. So you'll notice that I did all those problems just following the same basic steps. 1.5 over 2 is 0.75, and it's a negative because I divided by a negative 2. Great. So that was one of our learning targets, was just solving equations like that. Another learning target we had over this year was rewriting linear equations that were in mx plus b format. Okay, there we go. So that means I want to get y by itself. So I want to move the x's to the other side. So I subtract 2x because 2x minus 2x gets rid of all the x's on the left side. And then I divide by -3. So I end up with y equals -2 over -3. So that's 2/3. And 5 over -3. That's -5/3. Don't even grab a calculator for fractions. The answer is right there. You don't need to know that 2/3 is 0.6. You don't need to know that 5/3 is 1.666. You just write 5/3. All right, really similar process for number 8. I'm going to add 4x because that's the opposite of -4x. So 2y is 4x plus 36. I'm going to divide by 2. So I get y is 4 divided by 2. 36 divided by 2. And there we go. Remember that we do that because a lot of times it's easier to graph them when they're in mx plus b format. That was why we learned that learning target back in the day. All right, now we're just doing some graphing. When I look at this problem here, I can see that m is 2, b is -3. So I go down here to the y-intercept to -3, and I go up 2 over 1, up 2 over 1, as many times as I want. On the real test, I'd grab a straight edge, but that's actually pretty good. Usually when I'm drawing on my computer, they look a lot worse than that. For number 12, it is not in mx plus b, so I'm going to use the skill that we just worked on. I'm going to add 3x, because that's the opposite of -3x. So y equals 3x plus 6. So I can see my m, my slope, is 3. My b is 6. 1, 2, 3, 4, 5, 6. Up 3 over 1, etc., etc. That one's not quite as good, but there we go. All right, let's see how long this puppy is. We're already at 7 minutes. All right, maybe I'll call it good here, and I'll just do one video per page.